So on page 9, talking about slope today, our introduction to slope. We just got done talking about slope dude, right? So you know, puff puff positive, nice negative, zero fun, and then the worst word you could ever say in algebra. Undefined. Yes, undefined. Okay. Good. So, what's this graph say? It says the graph below shows a model of a skier elevation over time while skiing down a hill. Answer the questions below the graph. All right, so we have this graph here, correct? All right, it looks like the bottom here represents what? Time. Time in seconds. So how many seconds went by? That's really what these mean right here, these numbers. It looks like they go up in increments of 4. So you got 0, and then a space, and then 8. So most likely that middle line there is 4, and then 12, 16, 20, 24. And then over here on this side is your elevation. Do y'all know what elevation is? No? You ever heard like, so elevation is kind of like how high something is. If you're at a high elevation, that means obviously you're high up. Elevation can also be below sea level. Y'all ever heard of things like that? Things that are below sea level. So in this case, to ski, you got to be at a high elevation, and you're going to go downwards, right? So just off the bat, what kind of slope is that? Is that going to be a positive, a negative, or no slope? You think negative? Perfect. Yeah, because you can't do anything. I don't think anybody can ski going up. That'd be kind of tough. You just go down, you know, unless you're really getting after it. So a couple things here. A, it says, what does point A represent? So check out A. What does point A represent? What do y'all think A represents? Just by looking at it. Where are we at? It looks like he's at, that's a 220. And then where is he at here? He's at 18 seconds. 18. So what does A represent? What do you think? Where he stopped? It could be. After how long though? How much time has gone by for him to get to A? Close. What's in between 16 and 24? It looks like. Actually, no, I'm wrong there. It shouldn't be 18. It should be 20, right? Because it's going up in increments of 4. So, see how 0, that would be 4, 8, 12, 16, that'd be 20. So, that's saying after 20 seconds, what elevation is he at? Yeah, exactly. There you go. So, we're going to write that down. After 20 seconds, the skier is at 220 feet. After 20 seconds, the skier is at 220 feet. And that's kind of what it means. We have an input. Our input here would be 20 seconds. Our output would be 220. So all of this is really, the bottom part is telling you here is then after a certain amount of time has gone by, where the skier's at. That's kind of what this is saying. So after how much time has gone by, where is the skier? That's what this graph is telling you. All right, let's look at B. It says, at what elevation did the skier start? So what do you think? At what elevation did the skier start? 320. Good, yeah. At what elevation? That's a big one. Elevation. Remember, this side deals with elevation. Where did he start at? Notice at 0, if our input is 0 and we go straight up, he started at 320. And that's going to be, they said mark that as point B. So that's what we're going to do. Mark that as point B. So what elevation did the skier start? We'll put 320 feet. 320 feet. And to be honest with you, that is actually a crucial part of knowing how to set up equations for slope. where he starts is always going to be in the equation, or where something starts is always in the equation. So like if you're working a job and you start out with $0 and you make money throughout the day, where did you start at though? You start at 0, right? Let's say you had $50 in the bank though before you got started with a job and you made money. Where did we start from? All right. I said let's say in your bank account you have $50 in your bank account. All right, and throughout the day you make money, working at Subway. What did you start with? You started at 50. So you didn't start at 0, you started at 50 and you made money up there. So again, it's kind of the idea. The starting point is actually a very crucial part. Okay, it's also called the Y-intercept. All right, let's take a look at C here. It says, label the point 24, 200 with C. And what does it represent? So let's go to 24, 200. 24, 200. Try to label that. We'll go to our graph here. How would I label that? What do I go to first, Nigel? If I go to 24, 200. So what do I go to? Go to 24. Good. Yeah. And then go to where? Go up to 200. So I go all the way up to 200, which is right there, correct? So I'm going to go ahead and label that. And they said label that as point C. Label that as point C. All right, and what does that point represent? I mean, I guess just, huh? Yeah, what does that point represent? 24, 200. What does that mean? Feet. Good work. Yeah, that's what it means. That's exactly what it means. So after 24 seconds, the skier is at 200 feet. That's what it means. So we can write something like that down. After 24 seconds, the skier is at 200 feet. Yeah, that's really what that means. Okay, what's our input there? $24. There you go. Our input's 24. What's our output? 200. Remember, input is always your X. Output is always your Y. Output is always your Y. All right. Any questions on that one? Feel good about that? 24 seconds, 200 feet, elevation. Let's check out D. It says, how long would it take the skier to reach the bottom? Draw a line where the skier finished. Label that point D. All right, so really we got to keep the line going all the way until he hits the bottom of the mountain, really, right? So the bottom of the mountain, I'm guessing, would be at 0 elevation. So when will the skier hit 0 elevation? We got to continue to draw that line. So let's do that. So we're going to keep drawing this line, drawing the line. All right, so when does he finally hit the ground? After how many seconds? After 64 seconds. Good. Let's label that as point D. That's point D. All right, so at 64 seconds, how high is he off the ground? What elevation is he at? 0 feet. Yeah, there we go. Notice what I did there. I just kind of followed the in between the lines there. So usually how y'all are going to see graphs, kind of like this. When you draw the graph, if it goes, see how it goes through like the corner pieces? It goes through that corner piece, and sometimes it goes through the middle there. So notice when you draw a graph, it's kind of understanding where did it cross some of these corner pieces. Like that piece right there, that piece right there, that piece right there. If you can look at the graph and kind of notice where it's crossing those points, then that's going to help us out finding the slope. All right? But to answer the question, how long did it take the skier to reach the bottom? We would say 64. Is this minutes, seconds, hours? Y'all know? Seconds. Yeah, good work. Seconds. Good work, good work. All right. Now, these are some tougher questions right here. It says, how many feet did the skier descend down the hill each second? Use the following points to determine. So we really haven't talked about this. This is kind of more talking about actual slope, intercept form, and talking about how to find slope, which we're going to talk about in a little bit. So we'll come back to these questions on E.